Hello everyone. Quick shout out before we begin. Argentina, you're my top audience. Gracias. And Colombia, welcome to the chaos. Encantado de que estés aquí. Today we begin a brand new playlist about Home Assistant, because apparently I don't have enough projects already. Look, you see? Magic is what I'll need to make this project work. So the first device is a power consumption utility grid monitor using an ESP-01 and a PZEM module. This little board will tell me exactly how much electricity my house is eating, and probably make me cry. First step, removing the parts one don't need. PZEM terminals, gone. ESP-01 pins, gone. I place all the components on the board and start soldering. In the last video, my what am I got completely ignored. It disappeared faster than my free time. But this time, I'm making it impossible to miss. So get ready, sharpen your brain, because here comes today's what am I? I don't carry power, but I carry meaning. I'm not the wire, not the air, but what travels through them. Change me and nothing understands anything anymore. What am I? And everything is going great until I meet my new enemy, the 80-degree temperature fuse. This fuse has one job: protect the circuit. And it protected itself from being soldered. I burned one, then another, then 5 more. At this point, the fuse was winning, so I improvised a snap-in terminal system. No soldering, no drama. No more fuses screaming in pain. I'll check the board's conductivity again. Everything's working, the magic happens again. Next challenge, Pogo Pins. Why solder an ESP-01 when you can make your life way easier instead of harder? I printed this nylon resin bracket, heat soldered 2 pins through the board, and now the ESP-01 just snaps in place. No soldering, no stress. It's simple, practical, and even makes programming a breeze. Basically, it's like a tiny USB port, only way cooler. But first, I want to share something exciting. This project was only possible thanks to my sponsor, with JLCPCB. So let's visit the JLCPCB page and get this board ready for production. Just drag and drop and boom! The boards are instantly analyzed and show exactly what you will receive. They offer us total control. Quantity, thickness, color, everything you need to create the perfect board. Look, we can see the result of the board in 3D. What I love is the transparency. You adjust a setting and the price is updated in real time. They have industrial level features, but the interface seems to have been made for manufacturers like us. And if you're new, you can register right here. It takes a few seconds. Normally, I only order electronic boards, but this time I designed a 3D model and asked them to print it in nylon resin. Look, my first 3D printed resin part straight from the factory. And of course, here's the circuit board I designed for the power consumption project. Clean rails, solid finish, everything exactly as I planned. This nylon resin print is on another level. Now I connect the ESP-01 to the adapter and access my IP from Home Assistant. Inside ESP Home, I create a new device called Energy Consumption Utility Network. I tweak the code, name, registration, OTA, API, Wi-Fi. I download the firmware, upload it manually, and wait for the ESP-01 to come online. Eventually it does. After a while, a faint glimmer of hope appears. And there it is. The especially has finally been found. I was starting to think it would slip past my investigator's magnifying glass. I put the ESP-01 back on the board and connect the coil terminals. It actually looks like a real product, which is terrifying. And this is my PC with Home Assistant. Yes, it's a laptop without a screen, without a keyboard, without dignity. Just the motherboard inside the case as if it were on vacation. This is just a preview because soon I'll be building a case for it. And if you follow the channel, you know it's gonna be different. Different like a VW bus PC. And today's motto is, build with 10% skill and 90% hope.
All right, time to open Fusion. This is where the magic happens. I'm designing the case that will hold our power consumption board inside the electrical panel. It needs to be safe, compact, and preferably not look like it was made during a power outage. So I start sketching the base. Nice and simple, nothing too fancy. This thing is going inside the panel, not walking a runway. All right, the model is ready. Time to print it and see if reality agrees with my optimism.
Now let's install the board in the electrical panel. Now I need to say this clearly. Do not do this unless you know what you're doing. Electricity is spicy. I mount the board, attach the coil to the neutral wire, and connect neutral and phase. I turn the breakers back on, and the board lights up. Success! Or at least nothing exploded. In Home Assistant, I create a new consumption tab. I add current, energy, frequency, power, power factor, and voltage. Basically, everything you need to confirm that your electricity bill is too high. This is the first project of the Home Assistant playlist. More devices are coming, and soon I'll build the case for the Home Assistant PC. It's gonna be unusual, it's gonna be ridiculous, it's gonna be recrafting. Thanks for watching. See you in the next build. As you can see in the electrical panel, I have a transfer circuit breaker. Yes, it's for my off-grid system that I'm building. If you want to know more about it, type below so I understand you're interested and I'll make a video.